Welcome. Today we're diving into the publisher-subscriber pattern, often called pub-sub messaging. This pattern is a cornerstone for building scalable, decoupled cloud applications. Imagine a system where one component can announce events and multiple others can react, all without knowing each other's identities. This is the power of pub-sub. We'll explore how Azure services like Event Grid, Event Hubs, and Service Bus make this possible, and why asynchronous messaging is so valuable for modern distributed systems. Let's start by understanding the core problem pub-sub solves and how it fits into cloud architecture. Distributed applications components often need to inform others when something happens, but directly connecting every sender to every receiver quickly becomes unmanageable, especially as the number of consumers grows. Plus, not every consumer cares about every event. The challenge is, how can a sender broadcast events to all interested consumers without being tightly coupled to them? This is where asynchronous messaging comes in, allowing senders to announce events without waiting for responses or knowing who will receive them. Publisher-subscriber pattern introduces an asynchronous messaging subsystem. Here, how it works: the sender or publisher sends events as messages through an input channel. Each consumer, known as a subscriber, has its own output channel. An intermediary like a message broker or event bus copies each message from the input channel to all relevant output channels. This setup allows publishers to broadcast events without knowing the subscribers, and subscribers to receive only the events they care about. It's important to distinguish between events and messages. A message is simply a packet of data sent between components. An event, on the other hand, is a specific type of message that notifies other components about a change or action that has occurred. In pub-sub systems, events are packaged as messages and delivered to interested subscribers, enabling real-time or scheduled reactions to system changes. Pub-sub messaging brings several key benefits. First, it decouples subsystems, allowing them to be managed independently. Second, it boosts scalability and responsiveness as senders can quickly dispatch messages and move on. Third, it improves reliability, helping systems handle increased loads and intermittent failures. Pub-sub also enables deferred or scheduled processing, seamless integration across platforms, better testability, and clear separation of concerns within applications. Azure provides several robust services for implementing the publisher-subscriber pattern. Azure Service Bus, Event Hubs, and Event Grid are all designed to support scalable, reliable pub-sub messaging. These services handle message routing, delivery, and filtering, so you don't have to build your own messaging infrastructure. Other popular technologies include Redis, RabbitMQ, and Apache Kafka, but Azure's native services are optimized for cloud integration. Critical aspect of pub-sub systems is managing subscriptions. The messaging infrastructure must provide mechanisms for consumers to subscribe or unsubscribe from channels. This flexibility allows subscribers to receive only the messages they care about. Azure services make it easy to manage subscriptions, ensuring that consumers can dynamically join or leave topics as needed, without disrupting the overall system. Security is paramount in any messaging system. Access to message channels must be restricted by security policies to prevent unauthorized access or eavesdropping. Azure's pub-sub services support robust authentication and authorization mechanisms, ensuring that only trusted applications and users can publish or subscribe to channels. This segmentation also allows for network isolation between publishers and subscribers, further enhancing security. Not all subscribers are interested in every message. Pub-sub systems often support filtering mechanisms, allowing subscribers to receive only relevant messages. This can be achieved through topics, where each topic has its own output channel, or through content filtering, where messages are inspected and routed based on their content. Some systems even allow wildcard subscriptions for greater flexibility. Pub-sub systems, the order in which messages are received isn't always guaranteed. This means your system should be designed to handle messages in any order, and processing should be idempotent, meaning handling the same message multiple times won't cause issues. This approach eliminates dependencies on message order and ensures reliable processing, even in complex distributed environments. Sometimes malformed or problematic messages, known as poison messages, can cause failures. Pub-sub systems should prevent these from being reprocessed endlessly. Azure Service Bus, for example, supports dead letter queues to isolate such messages for later analysis. Duplicate messages can also occur, so the messaging infrastructure should support deduplication, or your processing logic should be idempotent to avoid repeated side effects. Messages in a pub-sub system may have a limited lifetime. If a message isn't processed in time, it might become irrelevant and should be discarded. Publishers can set expiration times, and receivers can check this before acting. Additionally, messages can be scheduled for future delivery, allowing for deferred processing or time-based workflows. This flexibility is crucial for building responsive, event-driven applications. If a subscriber can't keep up with the message rate, it's important to scale out. The competing consumers pattern allows multiple instances of a subscriber to process messages in parallel, improving throughput and reliability. Azure's messaging services support this pattern, making it easy to handle high-volume workloads without bottlenecks. Publisher-subscriber pattern is ideal when you need to broadcast information to many consumers, integrate independently developed systems, or support eventual consistency. It's especially useful when consumers have different availability requirements or when real-time responses aren't necessary. However, if you have only a few consumers or need near real-time interaction, other patterns may be more appropriate. Let's look at a real-world example. In Azure, you might use Service Bus to coordinate workflows and Event Grid to notify subsystems of important events. This architecture supports backend systems, client apps, APIs, and SaaS services, all communicating through queues, topics, and events. Authentication and security are managed through Azure services, ensuring reliable, scalable, and secure event-driven integration across your enterprise. Publisher-subscriber pattern supports key architectural pillars: reliability, security, cost optimization, operational excellence, and performance efficiency. Decoupling components improves resilience and allows independent scaling. Security is enhanced through segmentation. Cost is optimized by enabling event-driven consumption-based billing. Operational excellence is achieved through safe deployment and easy updates. Performance is boosted by allowing each component to scale as needed. PubSub builds on the observer pattern by introducing asynchronous messaging. Many implementations use the message broker pattern for routing. When designing your system, consider related patterns like request reply for bidirectional communication and priority queue for message ordering. Explore Azure's documentation and best practices to choose the right services and patterns for your needs. Wrap up, the publisher-subscriber pattern is a powerful tool for building scalable, decoupled, and reliable cloud applications. By leveraging Azure's messaging services, you can broadcast events, integrate diverse systems, and handle complex workflows with ease. Remember to consider security, filtering, scaling, and error handling as you design your solution. With PubSub, your architecture is ready to meet the demands of modern, event-driven application.